So let's compare once again the pons and the cerebellum. Here, I'm just reminding you, here is the pons, the base of the pons. This is the part of the pons that is married to the cerebellum, in particular to the cerebellar hemispheres. So this is big in us because we have these big, or they both got big together, the cerebellar hemisphere and the base of the pons. And here's the sheep, here's the base of the pons, here's the cerebellum. They're both connected. I'm going to just cut off the peduncle. I'm going to cut the connection. Okay, there you go. I am cutting off the cerebellum. There is no other structure in the brain that has so constricted an access. So the cerebellum, if it were not for these peduncles, it would not be part of the brain. It would float off. So that's the only way in or out. Were you going to say something?
Yeah, so are they connected to the hemispheres and not the vermis? Or how is the...
It's connected to, so this connection is to the entirety. It goes both to the vermis and to the hemispheres. So now we look down on it and we see this structure, which I haven't really talked about, but this is the fourth ventricle, and it's going to contain cerebrospinal fluid, and it goes right into this aqueduct, which I'm putting my probe into. And so it's going right into the third ventricle, which is part of the midbrain. And you can see I'm in midbrain. Here's the colliculi, the superior and inferior colliculi, the bizarrely large superior colliculus. Okay. So yes, small hemisphere, small basis pontus. Let's cut this mid-sagittally. I'm so sad because the pineal just came off. That was very unfortunate. It slipped off, but at the very least, what did I do? I cut it right on midline. Yay! Look at that. How do I know? Because there is the aqueduct. You see how that leads? That's a little channel that's leading from the fourth ventricle up here to this third ventricle, which I cut a little bit off center, but not much. This is the third ventricle. Let's get that little bit off. Okay, great. So fourth ventricle, aqueduct, third ventricle. And regrettably, I cut off the pineal. There it is. But the pineal would sit something like that. And so if the pineal grows, it presses right here. And that's why it presses right here. It can close this aqueduct, and you can imagine that that is a very vulnerable place where hydrocephalus could occur. If we look at it from the side, let's see, which side is this? Okay, we're going to look at it like this. So let's compare the sheep and the human. We don't have a medulla, but the medulla on here, we don't have a human medulla, but here it is. Here's the medulla, here's the spinal cord, here's the pons, here's the pons, here's the midbrain, here's the midbrain, here's the diencephalon, and here's the diencephalon right here. And then here's the telencephalon. So the same parts, they're proportionately bigger or smaller, but we've got the same parts. Okay, now the final thing that I want to do is explain to you about the ventricles. That's what we'll do next.